Uh, Students, I am very much happy to present this small work uh, to you, and what I am going to teach today is about tournaments. Okay, is tournament. You must understand that. What is a tournament? Tournament is an oriented complete graph is called tournament. Oriented complete graph is called a tournament. Take for example this. It consists of two vertices and one directed edge. Similarly here, second picture, it is again uh, a oriented complete graph because three vertices connected by directed edges. This also example for um, oriented complete graph. All these are called tournaments. Why we say tournaments? These vertices we are um, treating them as players, and this arc is treated as the winner. It implies he is the winner and he is the loser. So if three vertices are there, it means three players, and the the direction denotes the winner. In this competition between these two people, he is the winner, he is the loser. In the competition between these two people, this is the winner, this is the loser. Similarly in this picture too. Now let me describe about the property in the transitive property. We studied this in language trigonometry like that. If one line is parallel to another line, then they have another line is parallel to another line, the another line is parallel to another line, then first line is parallel to last line. That's called transitive property. Okay. Similarly here, if UV and VW are the two arcs in a tournament, that implies UW belongs to that tournament. I mean, if the initial point, final point, you join the initial point and the final point of an arc, that arc must also be in that particular tournament. Okay. So if that is the case, then we say that transitive property is satisfied. Now look at this picture. V1, V2, V3 are vertices, and we have the directed edges. Now look at this. V3, V2, V3, V2, V2, V1, V2, V1. So what is that? The first point is V3 and the final point of the arc is V1. So yes, the transitive property is satisfied. But if you take any other way, transitive property is not satisfied. Now look at this particular picture. In this particular picture you see that V2, V1 are the directed edges towards from V2 to V1, and another one V1 to V4, V1 to V4. Here V4, double 4 I have written, it is not V4, this is V4, V1 to V4. Now join these two, V2 to V4, V2 to V4. So direction is different. So transitive is not satisfied. Transitive is not satisfied, you see. Now next terminology here is Hamiltonian path. Hamiltonian path. Why we study this? Because the tournament we are going to study Hamiltonian path. Now look at this here. Okay, look at that. You see that uh, a picture here, but of course the direction is not given here. Okay, right. A, B, I, H, C, D, E, F, G. This is what? A graph. Am I correct? A path which should touch each and every vertices is called a Hamiltonian path. A path which touches each and every vertices in a graph is called a Hamiltonian path. Look at this picture here. A, from A to I to H, H to B, B to C, C to D, D to E, E to F, F to G. So look at this. So this is a path where each and every vertices are touching. So this is a good example for a Hamiltonian path. Hamiltonian path is a good example here. We cannot say that only one Hamiltonian path is there. There may be a lot of Hamiltonian paths there. Take for example B, A, I, H, C, D, G, F, E. Again, another Hamiltonian path. Why? Because this path also touches each and every vertices in this graph. Therefore, these two is a good example for Hamiltonian path. Now, let us go to the next slide. Okay, to know a little more about Hamiltonian path. This tournament have the Hamiltonian path? That is what our question. Okay, so suppose there is a tournament. Our aim is that whether there is a Hamiltonian path or not. That's what our next point there. But the PowerPoint is not working, it's not moving. That's the problem. Okay. Okay, we will start with this, and in another day I will talk to you about some properties of Hamiltonian path and the theorem in that. Thank you very much for having me with you for the past 10 minutes. Thank you.